Welcome to the deep dive. Now think about a tool we all know, a knife.
Hmm.
But I want you to kind of push that image aside for a moment, because
Yeah.
today we're talking about a knife. Well, unlike anything you've probably ever seen, or maybe even imagined,
Right.
we're going deep into the story behind something pretty unique, a leveraging chisel knife.
Interesting already.
Yeah, and it's not just about, a cool custom blade. It's really a dive into the cutting edge of designing with artificial intelligence. Collaboration.
Oh, okay. So human and AI working together,
Uh-huh.
or maybe struggling together.
Exactly. Our mission today is to explore how this one human designer's vision, super specific, really out there, pushed an AI right to its limits.
Mhm.
And in doing that, it kind of exposed a fundamental issue. AI's struggle with real novelty, with precise spatial stuff, because it's built on probabilities, right? Not actual understanding.
That's a key point. It's statistical, not conceptual in the human sense.
And this whole story, it really points towards the future. How we might actually co-create genuinely new designs. Things far beyond just, well, what the data says is probable.
Okay.
So let's paint the picture for you. We have this human designer. Clear vision, but really unconventional for a fixed blade knife.
Okay.
They were very explicit.
Yeah.
Not like any other knife you can find on the web.
Wow, okay. That's throwing down the gauntlet for an AI right there.
Totally. You can just imagine the AI kind of scratching its virtual head. It's like asking a baker for, I don't know, a spiral-shaped loaf of bread, and they keep giving you baguettes because, well, bread is usually long and thin.
That's a great analogy.
Yeah.
Because the designer wasn't just tweaking things. They had these really precise, almost counterintuitive ideas for this knife.
Yeah.
And every single feature,
Yeah,
driven by a deep sense of practical use.
exactly. And these weren't small details either. The absolute defining thing was this specific near right angle bend.
Hmm.
Initially, they were aiming for like 75 to 80 degrees
Oh,
between the blade and the handle.
okay. That is unusual.
Yeah. And it needed a totally straight edge, one that doubles as a chisel knife. Optimized for carving, for tough survival jobs. Ergonomics were huge. Think. Brute force meets surgical precision.
And critically, the intent behind all these weird features wasn't just looks. It wasn't just style.
Right.
The goal was real ergonomic synergy. You see, the chisel point and the handle.
Uh,
They were designed to be at the exact same near right angle from the blade's main axis.
okay, so matched angles. Why is that so important?
That alignment, it's absolutely vital. Imagine you're out somewhere, you need to carve wood,
Mhm.
maybe feather sticks for a fire, notch a trap.
Yeah.
That precise angle drastically cuts down on wrist strain. You can work for much longer without getting tired, and it massively improves leverage.
Ah, okay, so better power transfer.
Exactly.
Hmm.
For the tougher survival stuff, like prying things or betoning wood through a log, you get way better, more direct force transfer. The design also needed this unique groove for hooking on a poppet to unsheath it, and a distinct pinky guard sticking out from the pommel. Plus a striking surface, right in line with that bend, kind of behind the blade, and instead of a normal guard, a cutout in the blade acting as a finger guard.
So, yeah, very specific, almost like a multi-tool shaped like a knife, designed purely for function.
And here's where it gets really fascinating. Despite all those clear, super detailed instructions,
Mhm.
the AI just, well, it really struggled.
Yeah, this is the core of it, this back and forth, the human designer pushing, the AI just not quite getting it, especially that unique geometry. It was a real tug of war.
This is exactly where you start to see the limits of current generative AI models,
Hmm.
in a practical, real-world design job.
So what was it doing wrong?
Well, for instance, it kept making curved handles, even when the prompt explicitly said straight.
Hmm.
The designer even pointed out, kind of exasperated,
Yeah.
all knife handles are straight, this one should be as well. The AI seemed to be defaulting. Going back to what it thinks a normal knife looks like, it completely missed the radical brief.
Right. It's like it heard straight, but its internal database screamed, knife handles are usually shaped like this. And it kept messing up that bend, right? That's 75 or 80 degrees.
Absolutely. It often just gave back a totally straight blade. Or maybe a perfect but wrong 90-degree angle,
Mhm.
even when the text said otherwise.
And the other bits, the pinky guard, the finger cutout.
Often just missing. Or drawn incorrectly. You can almost feel the designer's frustration in the prompts. Things like, this has elements that are correct but is largely wrong. Where it matters, what is remaining from what I asked for?
Wow. Sounds like a real battle. Human creativity versus machine probability, pushing the boundaries.
And that struggle, it perfectly shows what we call regression to the mean in AI.
Regression to the mean. Okay.
This isn't just one limitation, it's arguably the central problem when you ask current AIs for something genuinely new.
Because it's trained on existing stuff.
Exactly. The AI's training data. It's overwhelmingly packed with conventional knife designs, millions of them. So when you hit it with an out-of-distribution, request something truly novel, totally unconventional like this designer wanted.
Yeah.
The AI's probabilistic nature, how it works fundamentally, it tends to subtly pull the output back towards the statistical average, the mean of all those knives it's seen.
So it's trying to be helpful in a way by giving you what's common.
Kind of. But it overrides the specific instructions. You'd ask for that 78-degree bend, and it might give you, I don't know, 10 degrees or 90 or just a straight blade, because those are statistically more common in its data.
So it highlights this core limitation, this tendency to stick to the common stuff. It produces variations, not breakthroughs.
Precisely. It struggles to generate truly groundbreaking forms from first principles if they deviate too far from the norm in its training data.
So, okay, that leads to the big question. Why was this so hard for the AI? What's actually going on under the hood that causes these constant struggles, especially with precision, with novelty, when the instructions were so clear?
Well, the core issue, and it's really revealing, it comes down to how these large language models, the kind used here, actually work. They're auto-regressive.
Auto-regressive.
Meaning they build the output text or image one piece at a time. One token follows the next, sequentially. Now, that works great for language, makes sentences flow.
Right.
But it really struggles with complex, multi-part instructions that depend on spatial relationships, like designing an object. Each prediction it makes is based on probabilities, what's likely to come next, not on a holistic, geometric understanding of the whole thing.
So it's not actually seeing the knife as a complete object, with all the parts connected and relating to each other. It's more like building it bit by bit and hoping it all lines up.
That's a good way to put it, exactly.
Yeah.
The AI is trained on text that describes objects. Then it learns to generate images based on those descriptions.
Okay.
It doesn't have an innate, built-in understanding of 3D space, or physics, or how shapes and angles actually work together in the real world. It doesn't have a mental image of a knife like a human designer does.
Where everything connects functionally.
Right. It might correctly recognize 78 degrees in one part of the prompt, but then fail to apply that accurately to the geometry in the image it generates in the next step. Because each part of its response is a fresh, probabilistic guess, not part of some grand, geometrically consistent plan. It's like a series of best guesses based on word associations.
And this sounds really similar to other AI problems we hear about, like hallucination. Is there a connection?
Yeah, you're absolutely right to make that link. These issues, the geometric mistakes, the regression to the mean, they aren't fundamentally different from AI hallucinations where it just confidently makes stuff up.
Or drift, where it wanders off topic.
Exactly. All of these things are just expressions of the model's underlying probabilistic nature. Its reliance on statistical correlation, what words or pixels usually go together, rather than true causal reasoning or logical understanding.
So it's hallucinating the picture because it doesn't really understand the geometry.
Precisely. It lacks a genuine geometric grasp of what a 78-degree angle is, physically. It's just interpreting words and trying its best to map them to visual patterns it's encountered before. The real difficulty arises when you ask for something unusual, something out of distribution, when the whole model is optimized to give you the statistically probable answer. It's essentially guessing its way through complex geometry, and that's why precision is so hard for it right now.
Okay. So after all that back and forth, all that struggle, the breakthrough, how did the human designer finally manage it? How did they get the AI to produce that final, precise, leveraging chisel knife schematic, the Model CK78? What were the magic prompts?
Well, it wasn't really magic, but more like smart, persistent strategies. And they're actually a great guide for anyone trying to push these AIs beyond the obvious. One key thing was deconstruct and reconstruct. Breaking the design down into its core parts, explicitly linking those parts to reference images, maybe, but crucially, emphasizing their relationships to each other and the overall concept.
So constantly reminding it of the big picture.
Yes, and the function. Like repeatedly calling it the leveraging chisel knife to reinforce its core purpose, not just listing features in isolation.
Got it. So not just add a pinky guard, but explaining how all the pieces work together for that specific goal, leveraging. That makes a lot of sense.
Exactly. Another powerful technique was functional anatomy. Framing the design around its main goals, things like maximum force transfer or ergonomic striking, giving the AI the why behind the what.
Okay.
And maybe most importantly, iterative refinement with explicit constraints.
Yeah.
using really strong, totally non-negotiable language for those critical features.
Like saying, exact.
Yes. The bend must be exactly 78 degrees, no more, no less. Or it must be a cutout within the blade itself, not a separate piece. Leaving absolutely zero room for the AI to wiggle around probabilistically or default back to common designs, the designer had to be incredibly specific. Relentless, even.
I can see how crucial that non-negotiable part would be, just hammering it home. Did they use any other tricks when just words weren't cutting it?
Yeah, analogical thinking seemed to help quite a bit. Bridging that gap between abstract ideas and a concrete shape
Oh, so...
by guiding the AI with metaphors. Like, imagine designing a specialized pry bar that also cuts and hammers. Or think of something shaped like the letter L, but with an ergonomic grip. This helps the AI sort of contextualize the novel design by linking it to a known function or shape, even if the final thing is totally unique.
Okay, and the result of all that persistence, the final schematic, Model CK78, was it worth the effort?
Oh, absolutely. The final schematic is really quite remarkable. It's precise, it looks functional in every detail, it's a fixed blade, full tang design.
Meaning the steel runs all the way through the handle.
Correct. For maximum strength, totally unbreakable. Total length is about 25 centimeters, so maybe 10 inches. Blade is fairly short, around 7 centimeters. Handle's about 18 centimeters for that leverage. Weighs about 7 ounces. So compact, but really sturdy.
That sounds like a serious tool.
It is. But the absolute heart of the design, the defining feature, is that 78-degree handle bend relative to the blade's axis. And crucially, it exactly matches the 78-degree chisel point grind on the blade.
Ah, that perfect symmetry they were after.
Exactly. This precise, almost mathematical alignment allows for incredibly balanced force application. It lines up perfectly with your hand's natural mechanics. This is that ergonomic synergy the designer was chasing from the very beginning. It's genuinely a revolutionary approach to grip and blade geometry.
So that angle isn't just weird, it's fundamental to how it works.
Totally fundamental. The handle itself, straight, linear, about 5-centimeter diameter roughly, fitted with scales made of micarta or G10.
Okay, those are tough, grippy materials, right?
Yeah, common in high-end knives.
Yeah.
Gives you a super secure hold, wet or dry. And that 78-degree bend right where the blade meets the handle. It positions your grip perfectly, protects your knuckles, keeps your wrist naturally aligned, minimizes strain, even if you're using it for ages.
And the blade itself.
Short, wide, and that entirely straight-edged chisel profile. No curves, no belly at all. Pure cutting and prying power. Made from 1095 high-carbon steel.
Known for toughness and edge holding.
Exactly.
Yeah.
And easy to sharpen in the field. It has a Scandi grind, that simple, robust V-shaped bevel. Great for carving, really strong.
And all those other little integrated features they fought so hard to get the AI to include, did they make it into the final design?
Every single one. Present and accounted for, and precisely rendered. You've got that distinct pinky guard at the end of the handle, gives you a really secure, non-slip grip, especially for pulling motions. There's a robust, flat metal striking surface right at the top of that bend, in line with the spine. So you can actually use it for light hammering. And that finger guard cutout, it's in the blade itself right below the handle. Lets you choke up your grip for really fine, detailed carving work. Super controlled.
And the pocket hook thing?
Yep. The pocket unsheathing groove is this clever hooked notch on the blade spine designed to catch on your pocket edge or belt loop. Lets you deploy it one-handed from the sheath in like under 2 seconds.
Wow. Yeah.
Plus, a sharp 90-degree spine for striking a ferro rod, fire starting, critical survival feature.
And the sheath to go with it?
Kydex polymer.
Oh.
Super durable, resists moisture. It's a tight friction fit, gives you an audible click so you know it's secure. And it has a reinforced lip specifically designed for that pocket hook deployment.
Class.
Belt loops, mullet straps, versatile carry options.
That is, yeah, a truly meticulously designed tool, purpose-built. And it came out of this, well, this struggle between human vision and AI limitations. But if current AI finds this kind of precision and real novelty so challenging, what's next? How does it get better? How does it become a real collaborative partner in design, moving beyond just recognizing patterns?
This is where the really exciting stuff is happening in research and development. People are tackling these exact limitations head on.
Like how?
Well, one big area is multimodal architectures, training AI on both images and text, but simultaneously, integrated.
So it learns the connection between words and shapes much more deeply.
Exactly, building a richer understanding, closing that gap between reading a description and actually seeing the geometry. so it can truly read and see at the same time.
Okay, so it's not just reading about knives, but seeing millions, understanding their structure, and reading descriptions all fused together.
Precisely. Another key thing is specialized training. Imagine fine-tuning an AI not just on random web images, but on huge data sets of actual engineering schematics, 3D models, CAD blueprints.
Teaching it the rules of the game.
Yes, teaching it the specific rules and constraints of geometry, angles, mechanical design. Moving it beyond just matching patterns to understanding engineering principles, the physics of how things fit and work, teaching it the grammar of physical design, you could say.
That sounds like a much deeper level of understanding, getting at the underlying logic.
It is, and then you have ideas like self-play. A bit like how AIs learn to master games like chess or Go.
How would that work for design?
You could have a generator, AI creating designs, and a critic, AI, evaluating them against really strict geometric rules and functional goals, giving numerical feedback.
So the AI learns by designing against itself, trial and error.
Exactly. It learns the rules and finds optimal solutions without needing constant human hand-holding. It becomes its own demanding teacher, pushing itself towards precision and functionality.
So it's teaching itself what works geometrically, functionally. That's cool.
Very. And building on that, there's learning from simulated worlds. Picture an AI agent inside a virtual CAD program.
Okay.
Its actions are commands. Draw this line, extrude this shape, measure this angle, just like a human designer uses CAD. The simulated environment gives precise numerical feedback on how accurate it is, whether it meets the specs.
So it learns cause and effect. If I issue this command, this specific geometric result happens.
Precisely. It develops a genuine internal model of space and geometry, moving way beyond just statistical likelihoods to a real understanding of cause and effect in the design process.
Wow. These approaches sound like they could really shift AI from just pattern matching to actual problem solving, real spatial reasoning, creative invention.
That's exactly the goal. That's the potential impact. Enabling AI to generate truly novel designs, geometrically accurate ones, functionally sound ones, from first principles, not just remixing what it's seen or getting stuck on out-of-distribution ideas.
We're talking about AIs that could actually invent with us.
Bringing entirely new forms, new functions into the world, things we haven't even conceived of yet.
And what a journey we've been on today. Following this really unique knife design from concept to, well, digital reality, witnessing that fascinating struggle, AI hitting its limits when faced with true creativity and the need for precision.
Yeah, it really showed both the potential and the current hurdles.
And exploring these groundbreaking solutions that promise to unlock whole new frontiers in design, it really shows that even now, with all this powerful AI, that human vision, that human persistence, it's still absolutely critical for driving real innovation.
Absolutely, the human element remains key.
So think about this. What's the next out-of-distribution challenge you might bring to an AI? What radical new designs, maybe just stuck in your imagination right now, could be unleashed when AI finally masters spatial reasoning, when it can truly invent alongside us, going way beyond just what seems probable?
That's the exciting question for the future.
Something to think about. Thanks for diving deep with us today.